This question comes from Max, who asks, what would happen if antimatter touched Earth?
Max, you've just opened the Pandora's box of physics. Antimatter isn't just psi sparkle dust. It's literally the opposite of the matter that makes up everything around us. One tiny collision, and we're talking fireworks that would make the 4th of July look like a flickering candle.
Let's start with the basics. Every particle has an antiparticle. Electrons have positrons, protons have antiprotons, neutrons have antineutrons. When matter meets antimatter, they annihilate each other in a burst of pure energy.
And I don't mean a little spark. We're talking E equals mc squared, the kind of energy that could destroy cities or planets, depending on how much antimatter we're dealing with.
So, what if a single gram of antimatter hit Earth? 1 gram might not sound like much. You could hold it in your hand. But the energy release would be equivalent to 43 kilotons of TNT. That's roughly twice the bomb dropped on Hiroshima.
Max, you've just got yourself a handheld doomsday scenario. And that's just 1 gram. A kilogram? Suddenly, we're in global extinction territory, equivalent to hundreds of Hiroshima bombs going off all at once.
The effects are immediate and terrifying. At the microscopic level, antimatter meeting air molecules would instantly convert both into high-energy gamma rays. Those gamma rays would radiate outward, vaporizing everything nearby and starting massive chain reactions.
Buildings, trees, rivers, all reduced to plasma in a fraction of a second. And don't forget the shockwave, supersonic air expansion that can flatten cities tens of kilometers away.
But the fun doesn't stop there. A larger chunk of antimatter, say a meteor-sized quantity, would not just destroy cities, it would destroy continents.
Imagine an antimatter comet striking the Atlantic. The annihilation would produce an energy burst beyond human comprehension. Tsunamis, global firestorms, shockwaves racing around the planet. It's Armageddon on a planetary scale.
Max, this is why antimatter experiments are kept under extremely strict containment. Even micrograms are handled with kid gloves and lots of lead. Interestingly, antimatter doesn't naturally exist in large quantities on Earth. Cosmic rays and particle collisions produce tiny amounts constantly, but the Earth's atmosphere annihilates it instantly.
So any realistic scenario would require humans transporting it. And storing it? Antimatter touches matter, and boom! Magnetic traps are used to suspend antimatter in a vacuum, away from normal atoms.
Max, it's like trying to hold a flame in your bare hands, only if it touches anything, you get a supernova.
Now, let's imagine an extreme containment failure. A lab spills a few milligrams of antimatter. That's enough to obliterate a stadium instantly. Even worse, the radiation released would be lethal for miles, and the blast could ignite secondary fires in surrounding areas. Emergency services? Overwhelmed. Cities? Destroyed. And don't think insurance covers antimatter accidents. Max, your policy would definitely have an asterisk next to that one.
On a global scale, if somehow a large deposit of antimatter reached Earth, the energy release could strip the atmosphere in localized areas, create massive climate disturbances, and trigger earthquakes and volcanic eruptions by shaking tectonic plates.
Even after the initial annihilation, the after effects, nuclear radiation, heat waves, atmospheric disruption, would make survival extremely difficult. Humanity wouldn't just face destruction from the initial explosion. The world itself would be permanently altered.
The takeaway? Antimatter is incredibly fascinating scientifically. It fuels imaginations in Star Trek and futuristic spacecraft designs. But in reality, letting it touch Earth is an instant apocalypse.
Max, it's the ultimate don't try this at home scenario.
Tiny amounts are safe only in highly controlled labs because any contact with ordinary matter releases energy beyond imagination.
It's like playing catch with a lightning bolt that also eats cities for breakfast. So, if you ever encounter antimatter, admire it from a safe distance. Appreciate the physics, the potential for science, but respect its catastrophic potential.
Max, you just asked a question that makes nuclear bombs look like sparklers at a birthday party. And that's what makes physics both thrilling and terrifying. If you enjoyed this explosive thought experiment, make sure to like, subscribe, and leave your next what-if scenario in the comments. Remember, science is fun until it annihilates your city. Thanks for watching, and see you next time for more dangerously hypothetical adventures in physics.